Hi everyone, and welcome to the Exactpro YouTube channel and session 2 of the Python for Machine Learning Bootcamp. Today we'll look into data types specific to Python. We'll start with an integer, which is a type of data that stores whole numbers. Integers are numbers that do not have fractional components. In Python, this data type can be seen as int. We've entered number 2 in the code cell, and with the use of the type function, we can see what data type it belongs to. You will see that from time to time, we will call a constant or a variable and see what data type this variable or constant belongs to. In this case, the number doesn't have a floating point, so Python reads it as a whole number or an integer. There are numbers that do have floating points. A floating point means that there's a fractional part, but its calculation is imprecise. Depending on the programming language or the data type of the number, the level of precision may vary. It's typically precise enough to be used in arithmetic operations. Floating point numbers, or floats, in Python are marked as float values. To mark its whole and fractional parts, we separate them with a point. Please mind that we can't use commas for this purpose. A comma would bring us to a syntactic error. So here's our data type. It's correctly marked as a float. The string data type. As we've mentioned before, a string can be created by enclosing the text either in single or double quotes. They have equal meaning. Besides, you can put an apostrophe. As you see, it looks exactly like a single quote inside double quotes, and it won't affect the syntax in any way. This apostrophe will be perceived as a symbol belonging to the string. On top of that, you can also create strings that are several lines long. To do that, you have to enclose them either in triple single or triple double quotes. And then using the Enter button, type your text and spread it over several lines as you see fit. If we execute the code, we'll see this line. Please mind that it now has characters that we didn't put in. These are the so-called invisible characters. They do not appear as you code, but they are there because we pressed enter, so the terminal backslash appeared in the system to allow parts of your string to be transferred to the next line. Now we can experiment a little with these data types. Please mind that if I'm adding 2 to 3 with both of them enclosed in quotation marks, then 2 and 3 are strings. And if I add them to each other like that, then instead of 5, I get 23, which is the sequence of these symbols as strings. We can convert these strings into integers. Naturally, in this case, my cell will have to have the symbols of the corresponding format. Namely, the strings would have to only contain numbers and not contain letters or other symbols that would impede the conversion. And after the conversion, we are able to add up numbers instead of strings. 2 plus 3 makes 5. The same can be done with floats. We can convert floats into strings. There's another data type called the Boolean data type. This is the data type that accepts 2 values, true or false. The constants or words indicating these values are reserved in the system for this particular data type. This means that you shouldn't name anything else using these words in Python. Think of them as constants that are already embedded into the system to mean either agreement or disagreement with a given condition. Python variables can be in different states. If we have a cat variable, which stores the information on how much water the jug contains, then we can consider its value as 1 if the jug is full. So cat knows that the jug is 100% full. If the jug is empty, cat will be aware of the jug having no, or in other words, 0 water. It may also happen that there's no jug, and cat can't define whether it's full or empty. In this case, you may raise errors if you decide to work with the quantity of this water. It can also happen that there's no cat to begin with, and you're just trying to access a variable that was never created. In that case, you'll raise an error while trying to access a non-existent variable. So the absence of values in a variable is marked with none. When the variable is executed, you'll get none, like here. If you try to output it, we won't get anything, and it makes sense because that's exactly what none means. Our next topic today is binary operators. Let's talk about what this means. Typically, there's an operator, usually a mathematical one, but there can be others too. So to be implemented, this operator requires two arguments. For instance, to add two numbers, we need to have two numbers, so these two numbers would be the arguments of the addition operator. What operators are there? There's the addition operator. As we said, it calls for two arguments. I have 1 and 1 here. The result of the operation is 2. There's a multiplication operator. The logic is the same there. In the addition operation, we added up two integers and received an integer, while in the case of multiplication, we multiplied an integer by a float, so we should receive a float as a result. This will happen every time in a similar situation. There's also a subtraction operator, and this is the first case of us bumping into a rounded-off calculation that's commonly made for a float. We're not going to get 0.1 as output. Instead, we'll receive this number. You see a number of characters following the first sign after the float, which represent the approximation of this float stored in the machine. This, of course, limits our ability to analyze these values. Among other things, we can also try division by 0. We know it's forbidden, so if we do it, we will get an error message. This is what errors look like. This is the error type, and here's the error message. More often than not, it's quite readable and it's easy to understand what exactly went wrong. The most important thing is to take your time and to try and figure it out. If you do get error messages, feel free to ask us questions in the comment section below this video. You could also consult your friends who are into programming. Eventually, you should find a person who will answer your questions. If not, do browse Stack Overflow or a similar resource. Just don't give up, your answer is out there. Now, arithmetic operations have priorities. You probably remember this problem from school. How much is 2 plus 2 times 2? The correct answer is 6 because multiplication has the highest priority. However, we are able to change the order of operations. In this case, the addition will take place first, followed by multiplication. I get 8.4 as a result. Overall, Python was created as a language for mathematicians, so it's replete with possibilities of arithmetic calculations. This also must be the reason why, of all the programming languages, Python is the closest to data science. It sure gave a powerful push to the creation of libraries used in data science. Next up is comparison operators. We can compare two variables, or let's say a constant and a variable, using this operator. It's essentially two back-to-back equals signs. Perhaps at first you'll be confusing it with 1 equal to sign, but please mind that 1 equals sign stands for an assignment operation and 2 equals signs stand for a comparison operation. As a rule, the logic is similar in many other programming languages. You can also perform your comparison using a not equal to sign, as well as greater than, less than, greater or equal to, and less or equal to. Each of these binary operators returns the Boolean data type. Let's compare 1 to 1.0. We will receive true. In this case, Python was able to compare an integer to a float and figure out that these are equal values. Here's an example comparison using the greater than operator, greater or equal to. And finally, take a look at another case that requires our attention. This returns false. As we remember from the previous example, 1 minus 0.9 will not be equal to 0.1. It will be a bit less than that. That's why this comparison hasn't returned true. If numbers like these need to be compared, there's a way to do it using the round-off error. We use the ABS function, which accepts the expression in parentheses using the absolute value of a number. That is, we have 1 minus 0.9 and then subtract 0.1, the same value that was used for comparison. Ideally, we should get a 0, but we know about the round-off error and the fact that we won't get a pure 0. So this value on the left should be less than 1 multiplied by 10 raised to the minus 10th power. The new operator, double asterisk, is the exponentiation operator. So that's why this reads as 10 raised to the minus 10th power. On the left of the comparison operation, we've received a value slightly different from 0 and smaller than the round-off error. That's why the result of the comparison is true. If we take a closer look at the outcome we've received, it's 2 divided by 10 raised to the minus 17th power. Now let's take a look at how exponentiation works. 2 raised to the third power is 8, and 2 raised to the third power multiplied by 2 equals 16. The exponentiation is performed first, followed by the multiplication of the result by 2. If what we need to perform first is multiplication, that is 3 by 2, and do exponentiation after, then we need to put the expression in parentheses. Our next topic is logical operators. We need them to create more complex conditions. For example, before we simply compared two variables which could or could not be equal to each other, but it happens that we need to create several such conditions. There are operators created for this purpose. The main ones are AND and OR. There are Boolean operators as well, so they return a Boolean result. The AND operator will return true when it has true variables on the left and on the right, meaning that both of its conditions are true. For example, if I have money for a long trip and I'm on vacation, then I can go on a trip. So I can only leave if both conditions are true. If at least one of them is false, then no trip for me this time. Next up is the OR operator. If I'm on the left bank of the river or on the right bank of the river, then I'm on land. In this case, it's enough if just one of the conditions is true. It can be both, but it doesn't have to be. One is enough to get true as a result of the entire operation. Last but not least, some programming languages have the XOR operation, but not Python. In Python, it's easily substituted by the not equal to operator. Let's look at the example. If I'm barbecuing and not running, or I'm running and not barbecuing, then I'm resting. This is an exclusive OR, meaning that I can only be doing one of these, so one condition should be true and the other one false. I can be resting while I'm either barbecuing or jogging. If I'm doing neither, then I'm not resting. If I'm doing both, I'll be too tired to consider myself well rested. So what do we get in the end? Let's look at this truth table, where A and B are Boolean variables. We can use the AND operator to create a condition or pass true and false variables to it directly. If both A and B are true for the AND operator, then we'll get true. And for the OR operator, we'll get true as well. For the not equal to operator, we'll get false, and so on for the rest of the combinations. If we look at the columns, then we'll get true for the AND operator only when both A and B are true. And for the OR operator, we'll get false when both A and B are false. And for the not equal to operator, we'll get true when A and B are not equal to each other. Here are some examples of use. There's the AND operator, to which we pass two arguments, which returns true. The OR operator accepts true and false, which returns true. Finally, let's combine these. The order of executing operations is crucial. AND is executed first, so all ANDs will be executed first. Similarly to multiplication in the mathematical operators. And OR here is similar to the addition operator from the mathematical operators. The AND operator will return false, since we have at least one of the false arguments. Then false or true will return the end result of true. Let's now change the order of our operations and leave the constants in their place. AND is still run first, and we still get false here. And the OR operator gets false and false as input, that's why the result is false. Traditionally, if we need to change the operator's priority, then we can use parentheses and execute the OR operator first, which returns true. And the AND operator's false and true combination will return false. Moving on to assignment operators. We can declare a variable. The important thing is to start it with a letter or an underscore, and not with a number. We can store whatever we want inside the variable. Let's say that our variable is x1 and it equals to 2, which is an integer. We can display the output. x2 will store true and x3 will store false, which is the result of comparison of 1 and 2. x4 will store true or false, the result of work of the OR operator. Let's look up x2 stores true and x3 stores false. If at least one of these is true, then OR will return true. So we get true as our output. Last but not least, let's now look at this unusual operator. This is the floor division operator. Its work is quite ordinary with positive integers. It discards the fractional part and only leaves the integer part. That's why the result of dividing 5 by 2 is 2, which is an integer. Normally, 5 divided by 2 would be 2.5, but taking into consideration the floor division conventions, the result is just 2. Next up is the modulo operator. In contrast, this operator returns the fractional part, or the remainder, left from the division. 5 divided by 2 equals 2.5, but if converted to a mixed number, it's 2.5, so this numerator of the mixed number is output here. If you've ever done long division, you might have received this remainder. Here it is. Everything becomes more complicated when we use the same floor division operator to divide a negative number. We're not getting -2, we're getting a little less, 1 less to be exact. There's also an alternative. If, let's say, you don't want to get a number that's less than -2 and want to get -2, then you can use the regular division operator. Divide -5 by 2, put the expression in parentheses, and make it an integer, which will discard the fractional part and doesn't care if the number is positive or negative. Let's look at the graph to see how it works. If we divide 4.5 by 2, then starting from 0, we will be able to fit 2 here twice. We will have the remainder of 0.5. Python will take the closest integer value to the left. That would be 4. So from 4.5, we'll get down to 4 that fits 2 twice. If both numbers are negative, we know that the minuses can be discarded, and the same underlying logic will work for these negative numbers as well. As far as one negative number goes, regardless of which one it is, the following rule works. Our scale will have the first 2, the second 2, and the third 2. The third one spans -4.5, so Python, just like before, will look at the next number that can be divided by 2 to the left of this number. This number is -6. It fits number 2 3 times, so the result will be -3. So this is pretty much how it works. At times it might seem illogical, but this is how Python works. If this is not your favorite alternative, then you can always use rounding up to an integer. Today's homework is create a Google Colab file and solve the following problems in 5 of your code cells. Here they are. This task mostly checks your attentiveness, how you pay attention to parentheses, and as always, it helps you get more confident with your coding skills. These tasks are quite simple. The expected output is provided above. Depending on where you put your parentheses, these results may store a margin of error. That's why if some of the terminal numbers don't match, that's to be expected. But in general, the result has to be about the same. If the result doesn't match the expected value, let us know in the comments below this video and we'll see what might have gone wrong. It's a wrap for today. Thank you so much for watching. We can't wait to see your comments to this video. Make sure you come to us with any questions or issues and let us know if this is helping you on your journey towards a career in data science. We would be really excited to see your feedback. Thanks, and we look forward to seeing you at session 3. Bye!